This tutorial will help you to complete the 4 assignments for homework number 7. Let's get started with the first one, which is plotting points. When you plot a point, you always start from the origin, and you follow along the x-axis first, and the y-axis second. The x-axis is left or right, the y-axis is up or down. So if we have the point -4, 0, that is left or right, and this number is up or down, always. Left or right, up or down. So the first thing we need to do is we need to start from the origin and move along the x-axis to the number -4. So here we go. And then along the y-axis, you stay at 0. Click your point, and you're finished. Let's try that again. The first number is 7. That's left or right. +7 is to the right. Then -6 down the y-axis. 1, 2, 3, 4, 5, 6, click, and we're done. Last problem. 0 on the x-axis, so I do not move left or right at all. -6 on the y-axis, negative is down. Click, and we're done. The next skill is identifying points. So a point has been plotted on this coordinate grid. You need to line it up with the x-axis and the y-axis and identify the values. So because I'm on the number line, if I were to go back up towards the x-axis, I would line up with the number 0. But on the y number line, I go down -1, -2, -3, -4, -5, -6, -7, -8 units. So my value there would be -8. Let's take a look at this one. Oh, this looks like the same one. All right, here we go. Here's the point. So it looks on my x-axis that I line up with 5, and on my y-axis, I line up with 7. So I write a 5 and a 7. Now for my next question. This one is also on the axis, but this one moves over to the right 7. So the first number gets a 7, but it doesn't go anywhere up or down. So the second one gets a 0. That's how you identify points. The third skill is identifying whether you have a reflection or whether you have a rotation. So what's difficult about the reflections is most of the things we've covered have been reflections across an axis like this or an axis like this. But there are also diagonal lines like -x and diagonal lines like +x that you can reflect over. So look what happens when I draw that. Well, that's a terrible drawing. But when I draw this line here, y = -x, you can see that this is a perfect flip. This is a perfect flip. So this is a reflection, and I know that it's -x because this line is going downhill. So that's how I knew it had to have a negative slope. So we're going to say this is a reflection over the line y = -x. Next. Ooh, this also looks like a perfect flip. A rotation would mean that it would turn to the side, right? And this would be facing upwards or downwards. So I know this is a reflection. And this is the line I cross over, so it's a reflection over the y-axis. Because this is the line of symmetry. You fold your screen right there, and it's a perfect match. All right, let's try this next one. 1, 2, 3, 4, 5, 6 units from the y-axis, -1, -2, -3, -4, -5, -6 units from the left to the left of the y-axis. That's a perfect reflection. If they are the same amount of units away from the line of symmetry, then it is a perfect reflection over the y-axis. All right. This one. If I were to draw those y = -x lines, you see how this is not a perfect symmetry here? That's definitely not a reflection over y = -x. Definitely not a reflection over y = +x, so it must be one of these rotations. Now a rotation 90 degrees would put you in the very next quadrant. A rotation of 90 degrees is a quarter turn. So since I'm not in these two quadrants, that must mean that it is a 180 or 2-box turn. 180 degrees about the origin. So let's go ahead and click this answer and let's watch it rotate. Let's watch it as it rotates. You ready? Here we go. See that? Perfect. All right, let's take a look at one more. You see how this, if I folded my paper, there's no way they'd perfectly overlap. This is definitely a rotation. Imagine your screen turning to the side here. So it's definitely not a reflection. So we can cross these off. Definitely not a reflection. Now, did we have a counterclockwise, which is this direction? Do we have a counterclockwise one time? Or a counterclockwise 1, 2, whoops, sorry, 1, 2, 3 times. You see that? That's 270 degrees. That's a 3/4 turn. Definitely a 3/4 turn. So let's watch this one as it rotates. 90, 180, 270. 90, 180, 270. 90 here, 180, 270. You see that? All right. Now for the last lesson, the last lesson is solving equations. So you're going to use your distributing feature here. 6x minus 6 equals 30. Use your inverse operations. 6x equals 36. Divide both sides by 6, and you get your final answer. This is some old stuff. You really shouldn't have any trouble with this. All right, let's try one more. Again, distribute. 2 times 7y. 2 times 7y is 14y. 2 times minus 1 is minus 2. And the answer stays the same. Add 2 to both sides. 14y equals 42. Divide both sides by 14. Y equals 3. Oops, that's crazy looking. Y equals 3. All right, that concludes our lesson to help you with homework number 7.